Hello dear student, welcome on this video lecture. In this lecture we will be moving ahead of vector analysis or vector understanding. In the previous video you have understood addition of vector, and now we will be moving ahead in vector algebra, the subtraction of vector. So let's say we have been given two vectors, vector A and vector B. And if somebody asks for a minus b, then we will say this is going to be subtraction of vector. But if we want, we can rewrite it as this is nothing but a vector plus minus b vector. Now if we read this in this manner, then we can claim a big thing. That means subtraction of vector is basically nothing but the addition of vectors. Right, so instead of writing b, what we are going to use a vector minus b, and if we write a vector minus b, then this minus b has to be added with vector a. So this subtraction of vector is less popular, and generally we always use, or most of the cases we use, as addition of vector, because if we are subtracting the two vectors, then this vector can be treated as a negative vector, and then this will be addition of two vectors, or we can call it as a c vector. Then this c vector will be minus b vector, then our operation will be a plus c. So if I call this as a c vector, so basically it will look like a plus c. So that means we are basically adding these two vectors together. Hence we can use all the concepts that we have understood in case of addition of two vectors. Okay, so let me illustrate a little bit more. Then we will be using the concepts of addition to get the subtraction of two vectors. And let's say what will be given to us. We will be given to us a, the magnitude of a, b, the magnitude of another vector, and the angle theta. Mind it, here theta is angle between a and b. So theta is angle between a and b. This is angle between a and b. It is not the angle between a and minus b, rather it is between a and b. So this is given to us. So let's try to draw the two vectors, and we will be trying to subtract these two vectors. So let's say this is a vector a, which we are going to use, and let's say this is a vector b. If we place the vector b like this, that means we are going for addition of two vectors a and b. We know that. So from here we can measure what the theta angle is. So let's say this is a vector. Okay, let me write this vector a over here, and this is b vector. And theta means the angle that makes between a and b as per our way of measuring these angles. So this angle is going to be theta. That means if we produce this further, this is theta. We know if we join this tail with this head, so that will become a plus b. So what is a plus b that we have already understood? This is a plus b vector. Okay. Now here we are not interested in a plus b. We have already understood what the a plus b is and how it is to be calculated. Our focus is more on this a minus b. So let's write this as a plus b, which we used to call as a resultant. Now in order to get a minus b, what we need to do, we need to reverse this vector b. So if we reverse this vector b, so you'll find this vector b will be minus b vector. So minus b vector will be in this direction, and it will have a same magnitude. So this will become minus b vector. Now since this is minus b vector, so we will be writing it as a minus b vector. And we are now summing this vector a with this minus b vector. That means this vector a, which was here, and this has to be summed with vector b that has been shown there. This was a vector, we are going to sum with this minus b. Then the rule of addition we can apply between these two vectors. So if we join this with this, this will become the new vector, which will be indicating the addition of vector a with vector minus b. So you'll find that this is going to be resultant for a minus b. Making sense or not? So this is vector a, this is vector b, this is angle theta. Angle theta is between a and b, and if we are interested in minus b, so this vector, that vector has to be created in opposite direction, that means arrow has to be downside. Then we will be adding this minus b with the vector a, so this will be a vector and summation with minus b vector, so this will become a plus of minus b, that means a minus b. So in order to get the addition we will be using this, in order to get the subtraction we are going to use this. Now we will be knowing that the magnitude of this component is a, the magnitude of this component is also going to be b, because this minus sign is talking about the direction, so this is going to be b in length, this is going to be a in length. Now the angle between a and minus b, which we are calling as a c, you can call it as a c vector. So if we call it as a c vector, that is a new vector, so we can claim something, that means mod of magnitude of b and magnitude of c, they are going to be equal to b. So this will have a magnitude b, a will have a magnitude a, and the angle between a and minus b, or you can say a and c, is going to be this angle. Now if we measure this angle, this is going to be pi minus theta. So that's the only change we are going to bring in. That means that will imply the angle, then the angle between a vector and minus b vector, which we are calling as a c vector, you can call it as a c vector as well, will be how much? This will be equal to pi minus theta. So if the angle between a and b is given to as theta, then the angle between a vector and minus b vector will be equal to pi minus theta. This we can make a difference. So in case of addition rule, we know there is a formula. We can get the formula for subtraction. That means we can have this. That means mod of a minus b. What the value of mod of a minus b, or resultant of a minus b magnitude, is going to be equal to, we will be using the same formula. That means square root of magnitude of first square, that is a square, magnitude of second vector square, second vector is minus b, its magnitude same as b we have talked about, so it will become b square, plus 2 times magnitude of first, which is a, magnitude of second, which is b, into cos angle between two vectors, and the angle between two vectors is now pi minus theta. It's not a theta, it's a pi minus theta. So basically in old expressions or formulas, we need to simply replace theta by pi minus theta. So this will be indicating the magnitude of difference of the vectors. Now if you know this, that's good. Otherwise you can remember now onwards, cos pi minus theta gets converted into cos theta with a minus sign. So it's becomes minus cos theta. So if we place this minus cos theta, you'll find there's going to be a minus sign coming in. That means magnitude is going to be a minus b, or magnitude of a minus b is going to be equal to, given by this formula, which will become a square plus b square minus twice ab cos theta. Making sense? Yes, so that will become a formula for us to get magnitude of difference of two vectors. So difference of two vectors a and b is given as square root of a square plus b square minus 2ab cos theta, where theta is angle between vector a and vector b, right? And what is the angle between vector a and vector minus b? It's a pi minus theta. So this is how we can get the value of magnitude of subtraction. Again, this subtraction is going to be vector, which is given by this picture, right? Moreover, we can also talk about what the angle they are going to make. So let's say this is angle, which we are indicating by angle, let's say alpha. So this alpha angle is going to be given by tan alpha. You remember that tan alpha, in case of addition, the only difference we need to make is replace this theta by pi minus theta. So this will become magnitude of b sine pi minus theta divided by a plus b cos pi minus theta. So this will become equal to b sine theta, because there is a rule sine pi minus theta is sine theta, so it will become b sine theta divided by a minus b cos theta. Using this formula we can find out the direction of difference vector, that means a minus b. So here what we have used is mathematical relation that sine pi minus theta is equal to sine theta. You can remember it. If you don't know, if you know that, that's great. So point is, what we need to do is replace theta by pi minus theta in the formulas of addition. And if we need to make the geometry, so which vector has to be subtracted, you make that vector and reverse, create the opposite of it. Making sense? So this is giving us magnitude, whereas this is giving us direction, and this direction of that vector is from the vector A. Now if you are interested to find the direction from the vector B, then you can place another tan beta formula that you have already learned. Making sense? So subtraction of vector is basically addition of vector, in which the second vector has to be reversed. And by reversing this, what the difference is going to come, the initial angle which is theta between these two vectors will be now pi minus theta. Okay, so these are the two important formulas that we use for subtraction of two vectors. Let's take an example and then it will become more clear. So here is an example. So let me write this as an example. You can read it, pause the video, you can solve on your own. Then you can come to see the solution, check your calculation and answer them. Anyway, the equation is given p. Sometimes we denote these vectors by bold letter. So this bold p is indicating p vector. So if we make this p as bold, then there is no need to put the arrow upside. So that means this bold is also indicate a vector quantity. So it's written as given p vector is equal to a vector plus b vector, and q vector is equal to a vector minus b vector. If the magnitudes of vectors p and q are equal, so they say magnitudes are equal, what is the angle between vectors a and b? So let's we start. There is a vector a which has a magnitude a, vector b which has a magnitude b, and the angle is theta we are looking at. So it says the magnitude of p is equal to magnitude of q. That means it is basically saying p vector mod value is same as q vector mod value. Now p vector is indicating the addition of two vectors, whereas q vector is indicating subtraction of two vectors. So we will be using the formula of addition magnitude as well as subtraction magnitude. So basically it's going to be a vector plus b vector magnitude is equal to a vector minus b vector magnitude. Now we have just learned about the magnitude of difference of two vectors, and we already know the magnitude of addition of two vectors. Now we know if these things are equal, we can always say the squares are also going to be equal, or we can put the simple value is going to be square root, this will be a square plus b square plus twice ab cos theta, where this cos theta, or in this cos theta, theta is the angle between vector a and vector b. Now on the right hand side we will find we are going to write similar type of expression in which we will write a square plus b square, and then we need to write minus twice ab cos theta. Mind it, this theta is same as the theta on the left hand side because this theta is angle between a and b. Now if you are agreeing to this point, then it's almost over. What we can do next is a little bit mathematics. That means we can square both sides. When we square both sides, so square root will go off, then you'll find it's going to be a square plus b square both sides, which will get cancelled out. If I write directly, it's going to be twice ab cos theta, that will be left from left hand side, and on the right hand side we will be finding minus twice AB cos theta. Now if we combine them by bringing one side, so it will come 4AB cos theta equal to 0. You will realize that 4 and AB, they cannot be 0 because A and B, they are vectors, they should have a magnitude. So cos theta has to be 0. So if cos theta has to be 0, so what should be the value of theta? We can identify the value of theta is going to be 90 degree, which is going to be written as pi by 2. So we will look at the options and pi by 2 will be marked as a correct option. Right? So here we can use the magnitude of subtraction of two vectors as well as magnitude of addition of two vectors. Now the same question can be tried, no doubt, using this geometry. Now if I use the geometry, so we can say, let's say there is a vector A, right, and then we need to say there is a vector B as well. So this A vector and B vector has to be operated, once for addition, another for subtraction, and we need to place this B in such a way so that the magnitude of addition and magnitude of subtraction becomes identical. Now you remember, if I place this B in this manner, then you'll find addition will be this, for subtraction it is going to be like this. So this addition will have a more length as compared to the subtraction. To make them equal, you'll find we should place B some sort of this. If I say this is our B, then you'll find minus B is going to be perpendicularly downside. So this will become minus B. Making sense? Then you'll find as far as the lengths are concerned, they will have a same length. So this is going to be A in magnitude, this is going to be B in magnitude, this is going to be again B in magnitude, but this is going to be minus B vector. Then you'll find the length of both addition vector as well as subtraction vector is going to be equal. So this length will be equal to this length. That means we can say this addition as well as subtraction, they are identical. So here we will be able to claim that this is mod of A plus B, A vector plus B vector. Here I have used a small letter, and you can write this in the capital letters because here in this question capital letters have been used. So these two vectors or lengths will be identical only if this becomes 90-degree angle. So we will say the angle between vector A, which is in this direction, to the vector B, this angle has to be 90 degrees. So this theta is going to be 90 degrees. So from here we can remember this as a factual information. Whenever A and B are perpendicular, then you will find the magnitude of addition is same as the magnitude of subtraction. Okay, so this is an example that relates addition and subtraction together. Now let's move ahead and talk about multiplication in vector algebra. Well, so let's proceed further and talk about multiplication of vector or vector multiplication. In vector multiplication, let's first talk about a point. That point is written over here. It says multiplication of a vector by a scalar. Now, till now we have talked about addition and subtraction of two vectors in vector algebra. So if there is a vector A, we can add with vector B. Now what we can't do is, that means we cannot add vector A with some scalar B. That means a vector cannot be added with a scalar. In order to add one vector, we need to have another quantity as a vector. Neither we can subtract a vector with a scalar. So we cannot do this kind of operation, but we can do this kind of operation. Right? So in addition and subtraction, both the quantities involved should be either vectors or scalars, and in vector addition they must be vectors. However, in case of multiplication, we can multiply two vectors as well as we can multiply a vector with a scalar. So in this point we will be learning what happens when a vector is multiplied by a scalar. So let's say lambda is a scalar quantity and A is a vector. So if we multiply this lambda with A, so this will become lambda into A. So whenever we multiply a scalar with a vector, then the resultant is also a vector. So this is going to be a vector quantity. That means when a vector is multiplied by a scalar, then the overall quantity is a vector. Since it is a vector quantity, so it will have its own direction and its own magnitude. So what will be happening for the magnitude of this quantity? So we'll say magnitude of this quantity is going to be mod of lambda into a. Now this mod has some properties. It can be distributed, so it will be mod of lambda into a. So this magnitude of a will be a, and mod will be applied over the lambda. Lambda is a scalar, so that means magnitude will become mod of lambda into a. So that means this is going to be positive because we know the magnitude is positive, which means that this vector will be multiplied by lambda factor. That means magnitude of that vector will be changed by lambda factor. So whatever the quantity we multiply with, scalar quantity, then that entire vector becomes scalar quantity times that vector's magnitude. And okay, so if we try to show it pictorially, that means if this is a vector a, let me use this proper straight line. So this is a vector a, and we are multiplying this vector a by lambda factor, then you'll find its length is changed by lambda factor. So its length changes by the same factor. So this is vector a, and if we are multiplying with lambda times, then the vector will become lambda into a, then the length of that vector will become lambda a, where lambda is going to be that scalar quantity. Now if lambda is more than 1, then you'll find the length will increase. If lambda is less than 1, then the length will decrease. But in either case, you'll find it's going to be lambda times a vector. That means its length will be mod of lambda times a. Making sense or not? So this will be the case. As far as the direction is concerned, what we will call about the direction? Our direction will depend on lambda's sign. That means a scalar quantity sign. So direction, if lambda is positive, then lambda a vector will have same direction. Its direction will be same as a vector. Same as a vector. That means the picture that I have shown over here, we can say with guarantee this lambda is a positive number. That's why the directions are same. But if lambda came out to be negative, or we are multiplying with a negative vector, then we'll find the direction of lambda a vector will be opposite to a. Opposite to a. So this is effect of multiplying with a scalar a vector. So when we multiply a vector by a scalar, then this effect occurs. So the direction changes depending upon the sign. If the sign is negative, that means we know if we multiply by negative number, that minus sign will be changing the direction of vector, and that number will be multiplied as a factor in its magnitude. And a simple example can illustrate it much better. Let's say we are having a vector a, and what happens for vector when we multiply with lambda. So let's say lambda value is a 3. So in this case we will be having 3a vector. This 3a vector will keep that vector in the same direction because 3 is a positive number, and it will increase the length 3 times. However, if we take this lambda as, let's say, -2, then we will find the magnitude of lambda a, this new vector, this magnitude is going to be twice time a, because it will increase by 2 factor, but the direction will be opposite because this is a minus sign. So we will say the vector will be increased by 2 factor, however the direction of that vector will be opposite. So if I want to show with this direction as well, so this can be picture for this. Let's say this was vector a for the first case, then this lambda a or this 3a will be some sort of this. That means the length will grow by 3 times and direction will remain the same. However, in case of second, which I have shown in this, if this was indicating a vector initially, then we will find the lambda a vector will be indicated like this. It will be again a vector, but it will be in opposite direction because of -2 factor, and its length will be twice of it. Okay, if you are able to focus, then you will be getting it what's going on. That means it's trying to say, if this is a vector a, then this is a 3a vector, and this this is a boundary, you can say. Two example, one is this side, another is this side for lambda values. And if this is a, then you can say this is indicating -2a. And what this minus sign is indicating, this minus sign has reversed the direction of a in the opposite direction, or reverse the direction, and this was plus, so the direction remains same. So that's the rule basically. If the constant or the scalar that we are multiplying is a positive, direction of that new vector remains same as the old one, and if that is negative, then it's opposite. Moreover, this lambda, if lambda is more than 1, then the length of the vector increases. If this lambda is less than 1, then the length decreases. In both the example, we have taken lambda's magnitude more than 1, hence the length later on has grown up. Making sense? So whenever we multiply a vector by a scalar, what happens? Magnitude changes, yes. By what factor? By the factor of magnitude of scalar. And what happens to the direction? You say direction remains same if that scalar quantity is positive, and direction gets reversed if that scalar quantity is negative. This is the conclusion of this particular point. Okay, now let's move ahead and talk about multiplication of two vector quantities. So let's begin with the multiplication of two vectors. So here we will be multiplying two vectors. Let's say vector A is given to us and vector B is given to us. These are the two vectors. That means they will have their own magnitudes and directions, and we want to operate a multiplication between these two. Prior to this, we have talked about multiplication of a vector by a scalar, and we have also talked about addition and subtraction of two vectors. Now let's recall multiplication of two scalar quantities. So let's say if a number is given to us as a 2 and b number is given to us as a 3. Let's say these are scalar quantities a and b, or let me write it differently, x and y, so that there is no confusion. So let's say x is a number, scalar quantity, which is 2, y is another scalar quantity, which is 3. And if somebody says find the product of these two quantities, so we write x into y. So this x into y will be written as 2 into 3. Now we can also write this x into y as 2 into 3, maybe in this manner. Sometimes we also write it as 2 into 3, and sometimes we simply write as a 2 into 3. We know all these things are going to deliver the same number. This is going to be 6, this is also going to be 6, this is also going to be 6. So I'm just trying to write what we do in case of scalars. So if one number is given as a 2, another number is given as a 3, and somebody says find the product, multiplication, or this type of product, so what we do, we simply multiply them. How we write is, sometimes we put the cross in between, sometimes we put a dot in between, and sometimes we put within the bracket. That indicates we are going to multiply them. And we also can note on this scalar, this particular example, that if we are multiplying a number with another number, that means if we are multiplying one scalar with another scalar, then our answer is also a scalar. So scalar product of this scalar product of two scalars is going to give a scalar number. So product basically gives a scalar number, right? This happens for a scalar we know about. But in case of vectors, story is quite different, because vectors, they carry their directions, so we need to take care of that. So vectors product or vectors multiplication is defined in two different ways. Now it's going to matter whether we are using the cross symbol in between that will have a different meaning. If we are going to use as a dot symbol between the two vectors, it's going to have a different meaning. And if we are putting like this, that may have some another meaning, right? So we define this multiplication of two vectors as two types. So there are two types of multiplications, whereas in case of scalar we have only one type of multiplication, that's this into this, and that gives the answer. So one is going to be known as scalar product. We need to take care of the nomenclature that we are going to use. Scalar product. So we will say it's a scalar product, which is also known as dot product. Dot product. Here in case of scalars we used to use term like multiplication, 2 into 3, 2 multiplied with 3, or 2 product with 3, right? So here we need to take care of the language. First type of multiplication will be known as either scalar product or dot product, and the second case will be known as vector product or cross product. Cross product, and both of them will have an entirely different meaning. So we will be learning their meaning one by one. So what this scalar product and dot product is going to be we are going to write vector A and we are going to write vector B. If we place a dot in between, as the name suggests, so it will be read as A vector dot B vector. So it's A vector dot B vector, that's called dot product or scalar product. Now if we place a cross in between A and B, so this will be known as A vector cross B vector, and this will be known as vector product or cross product. So dot will have a different meaning in multiplication of vectors, cross will have another meaning in case of vector multiplication. So we need to be very careful to write and observe whether there is a dot or whether there is a cross, right? They cannot be interchanged, they are entirely different. And if someone writes like this, A in bracket, B in bracket, then we will say this will have no meaning, this has no meaning. No meaning. So in case of scalars, you have seen all of them cross, dot, or putting in the bracket, they yield the same answer. Whereas in case of vectors, these all have different meaning, or they all yield different answer. What this is going to yield as an answer we are going to discuss, and what the cross is going to give us an answer we are going to discuss, and writing this will have no meaning. Similarly, if someone writes A and B without writing anything in between, this is also of this category. That means this is not defined and it does not have any meaning. So you should never write A vector, B vector without writing anything between. Now if you put the dot, it will have a meaning like this. If you put the cross in between, then this will have this meaning. If you don't put anything, it does not have any meaning. So avoid writing this format or this format. Be clear whether you are writing dot or you are writing cross. So this will be known as a dot product. This is going to be known as a cross product. What their meanings are, what they interpret, that's what we are going to learn in this video and in further videos. Okay, so let's move ahead one by one. So first is the dot product, which is also known as a scalar product. So if we have been given vector A and vector B, and we operate if this symbol, so the dot product of these two vectors is defined. So these products have been defined in a particular fashion. So A dot B is defined as magnitude of vector A, so we will write the magnitude of first vector, then magnitude of second vector, that's the B vector, into cos theta, where theta is angle between vector A and B. This can be written in a simplified version. That means mod of A can be written by simply letter A. So we will be writing A vector dot B vector will be giving us A, which is magnitude of A, B, which is magnitude of B, into cos theta. So this becomes the definition of dot product between these two vectors A and B. So if vector A is known to us, vector B is known to us, and dot is in between, then we will find on the right hand side it's going to be magnitude of A, magnitude of B into cos theta, where theta is the angle between vectors A and B. So theta is angle between vector A and vector B, and this is angle we know how to measure it between the two vectors. Now we call this as a scalar product because of a reason, because you see on the right hand side, A is the magnitude of vector A, B is the magnitude of vector A, that means A is a positive number, B is a positive number, cos theta is also going to be a number. So these all numbers putting together will give us a number. That means there is a no direction involved. Since there is a no direction involved, so you'll find this is going to be a scalar quantity. That means the result of dot product is a scalar quantity. That means A dot B is a scalar number. So we can say this A dot B, that means we are multiplying two vectors. If in this dot fashion, then this is going to convert into a scalar. So A dot B is a scalar, it's not a vector. Now it's different than the case of scalars. We have seen the example, if we multiply two numbers we get a number in return, right? But this is not the case in this particular product. If we are multiplying two vector quantities with this dot fashion, we are not going to get a vector quantity, rather we are going to get a scalar quantity. So two vectors can be multiplied to get converted into a scalar quantity. It's a very different phenomena, and this is a scalar because the way we have defined is right hand side is a scalar, hence left hand side must be scalar. That means A dot B must be scalar. So if the two vectors are multiplied in dot fashion, hence they becomes scalar. That's why this is also known as scalar product. Making sense or not? Yes. If it is making sense, then we can go ahead. Now we can talk about some more points related to this definition or based on this definition. This is a scalar quantity, right? Now let's say talk about this scalar number, whether it's going to be positive or negative or zero. You see this A is a positive number, B is a positive number, so A into B will be positive. Cos theta is going to decide whether this A dot B is a positive or not. And we know if theta is less than 90, cos theta is positive. So we will say A dot B will be positive, that means greater than 0 if theta is less than 90 degree. So if the angle between these two vectors is less than 90 degree, then you will find that the dot product of these two vectors will be positive number. Moreover, this A dot B will become negative if theta is more than 90 degree. So if theta is greater than 90 degree, then you'll find it's going to be negative up to 180 degree, you know, and 270 degree, because you know in the coordinate second quadrant and third quadrant this cos theta remains negative. So for more than 90 degree case, you are going to get A dot B as a negative because cos theta will become negative. And the next point that we can connect from here is this A dot B is going to be 0. This is going to be 0 if what? Theta is equal to 90 degree. Now this is going to be true both ways. So this will become an important relation for us that will be very useful in many of the cases. That means if theta is 90 degree, then a dot b equal to 0. That means two vectors are perpendicular, then you'll find their dot products is going to be 0. So let me write this in terms of language because it's important. So we can say this is basically indicating if two vectors a and b, if vector a and b are perpendicular to each other, that means if a vector is perpendicular to b vector, then we can say with guaranteed, then we can say the dot product of these two vectors must be 0. Now this is going to be widely used in future, and many of the time there have been questions in the examination based on this. So it will ask you to find some value if vector a and vector b are perpendicular to each other. So what we are going to do, we are going to put their dot and we will make it 0. As soon as we make this dot product 0, we will get one equation out of it, and then from this we can find the unknown quantity. So whenever the two vectors are said to be perpendicular, one equation is always ready. That means their dot product is 0. Making sense or not? Yes, it should make sense. Now if it is making sense, we can go ahead and talk about some more points. Now you see, like a dot b has been given as ab cos theta. Now if we write about b dot a, then we will be writing the magnitude of b, magnitude of a cos theta. And we know in scalar numbers, if we do ab or ba, they will yield the same result. What I'm trying to say is that in case of dot product, if we say a dot b or we say b dot a, both will have the same value. So that means a dot b and b dot a, they result the same value. That means there is no difference whether we are putting first vector first or second vector first. So a dot b is always equal to b dot a. This is again an important property of dot product, which may not be true for other products. In fact, you will see for cross product it's not going to be valid. Moreover, we can also write that it's a distribution law is always also followed, like a dot b plus c. Let's say we are doing this. That means first we are adding two vectors b and c, and then we are making this vector as a dot with a vector. Doing this is same as to do this. That means you can go, or you can take this a inside. That means it can be written as a dot b vector plus a vector dot c vector. So it can be distributed over addition or subtraction. That's also valid. So basically there are some properties of dot product that I have listed, and I am hopeful that you are getting these properties. First of few are related to the value of theta and their values positive, negative and 0. This 0 is very important, and this says you can write a and b interchange. It doesn't matter, because on the right hand side we are going to get the same value. Hence left hand side will be equal whether it's a dot b or b dot a. And this talks about the distribution of a. If there's addition or subtraction, then dot product can be taken inside and can be operated in each of these terms. Let's carry with some more properties of this dot product. So a dot b is ab cos theta. We have talked about the sign of a dot b as well as their distributive and commutative law. Now some more important uses of this. One of the most important use of this is to find the angle between these two vectors a and b. So if a and b are known to us, we can find the cos theta out of it. So from this formula, if we are interested in finding the cos theta, you can easily see we can find this cos theta. For that sake, we need to divide both sides with a into b, which are the numbers. So it will become a dot b divided by ab. That means magnitude of a, magnitude of b. So this is a formula that we can use to find out the angle between two vectors a and b. We are going to use this formula extensively whenever the angle between two vectors are going to be required. Now we can further rewrite this in this manner, because this is a vector, so we can divide this a vector by a and put the dot in between. We can divide this b vector by b. If you remember the very basic definition of vector, so vector divided by its magnitude yields into unit vector. So this will become unit vector, that means a cap dot b cap. So basically a cap dot b cap is the cos theta. So we can remember this as well. So if we need to find the angle between two vectors, what we need to do, we need to find the directions of these two vectors and perform the dot product. So cos theta is equal to a cap dot b cap, you can call this, or you can remember cos theta is equal to a dot b vector divided by ab. So that's an important property of cos theta that we can remember and we are going to use in future. We can go further and talk about some more important aspect of this. Let's say two vectors are identical, that means a vector is a, b vector is also a. That means what we are going to do, we are going to perform a dot a. So if we do the dot product of a vector by itself, then we are going to find it is going to be magnitude of first vector, magnitude of second vector into cos angle between the two vectors. We know a vector will have a zero angle with itself, so this theta will become 0. So if this theta will become 0, so it will become cos 0 is 1, a and a will become a square. So this will give us another important result that we can remember. This a vector dot a vector is basically mod of a vector square, that means magnitude of a square. So I'm writing simply a, basically it's indicating mod of a, which is a square. So this another important property of dot product is, that means a vector when undergoes dot product with itself, the answer is that vector's square. Making sense or not? So cos theta, that means we can find the theta, the angle between two vectors, if we are able to perform the dot product. And dot product of two vectors or a vector by itself is the magnitude of that vector square. Now we can use this property to find out some common things which are very useful in calculations. Let's say we talk about I cap. I cap, we know I cap is a vector, that's a unit vector in direction of x. And if we do the dot of this I cap with I cap itself, so what the answer is going to be? We know the same vector dot with the same vector is going to be magnitude of that vector square. Now we know this I cap is a unit vector, that means magnitude of it is 1, so it's going to be 1 square. 1 square is 1. That means whenever we get I dot I, it's going to yield as a 1. Similarly, if we do j cap with itself as a dot, so j cap dot j cap, you know this j cap is a unit vector, so unit vector dot itself is going to be yield as a 1. Similarly, if somebody asks to find k cap dot k cap, can we find what the answer of this k cap dot k cap is going to be? Yes, we can find it out, it's going to be 1. In fact, any vector having unit, that means any unit vector a cap dot a cap, if we are interested, it's always going to be 1. So this is an important result we need to keep in mind. That means dot product of a unit vector by itself is always unity, that's 1. And it is basically coming using this result. Making sense? Now since we are talking about I cap, j cap, k cap, so we have talked about the values of I dot I, j dot j, k dot k, all are equal to 1. Let's talk about their dots with the another values, like I cap is getting dot product with j cap. So they are different vectors, so what we are going to use, we are going to use the dot product formula, which is over here. We write the magnitude of first vector, that means magnitude of I cap is a unit vector, so it's going to carry magnitude 1. Then magnitude of another vector, which is again unit vector, and magnitude will be 1. Cos angle between I cap and j cap, because we know I cap is in x direction, and the j cap is in y direction. So angle between these two vectors is going to be definitely 90 degree. Since angle is 90 degrees, so cos 90 will become 0, then you'll find this is going to be 0. That means whenever we multiply I cap and j cap in dot fashion, answer is going to be 0, because I cap, j cap, they are perpendicular vectors and dot product of perpendicular vectors is 0. Similarly, if somebody asks what is the value of j cap dot k cap, can we think of? Yes, we can think of. You can also do so. Since j cap and k cap, they are in perpendicular direction, this is y direction, this is z direction, so perpendicular vectors dot product is always 0. Can we say similarly k cap dot I cap? So if we are making the dot product of these two vectors I, j, k, any of these two, then you are going to find the answer to be 0. If we are making their dot with themselves, then answer is going to be 1. This is extremely important. We need to do practice, and we need to get used to of these things like anything. So we need to remember these things quickly, and we can solve the problems based on this. Once you have understood this, then now we will be able to find out the value of a dot b. Now how we are going to find this value of a dot b, we can see in the next slide. So let's say a vector is given as a1 I cap plus a2 j cap plus a3 k cap, and b vector has been given to us. This is b vector, so let me erase it and write it as a b vector. So b vector has been given to us as b1 I cap, b2 j cap plus b3 k cap, and we are interested to find a dot b, and we are looking for a dot b. So how we are going to get this a dot b out of these two vectors if they are given in component form? So what we are going to do, we are going to put the a vector, which is a1 I cap plus a2 j cap plus a3 k cap. In questions, these will be numbers which will be given to you. You can place there. Then we will put a dot in between because we are performing dot product, and we will write the b vector, which is b1 I cap plus b2 j cap plus b3 k cap. So what I have done, nothing special. I have just put the value of a and the value of b, so these two vectors, and in between dot product. Since we have talked about that there is a distribution law that is valid, that means we can distribute this entire vector over these terms. Basically that indicates we can expand this dot the way we do multiplication in case of scalars. So we will be multiplying all these numbers with all these numbers. So let's say I start with this first, and this term is getting multiplied with all the three terms of b. Then we will take this term inside this bracket and multiply with all of them. Then we'll take this and multiply with all of them. You can start in either way. You can take this and multiply with all of them. All are going to true. And we also know that this here in dot product, it does not matter which term you put first, because we have talked about a dot b is equal to b dot a. So we should not be worried about which term has to be written first and which term has to be written later on. So let's say start with this. So I'm taking this inside. So this a1 is going to multiply with b1. So I'm going to write as a1 b1. These are the numbers, so they will be taken common as. But this I is a vector and this I is a vector. In between there's a dot. So this will become I cap dot I cap. So the dot has to, between the vectors, this dot has nothing to do with these scalar numbers. So we will multiply these scalars and we will be putting the dot between these two vectors I cap dot I cap. Making sense? Now next, this term will be multiplied with this term b2. So we will get it as a1 b2, and from this side vector was I cap, and in between dot this side vector is j cap. So it will come I cap dot j cap. Then we will take this multiply this first term with this last term. We will get it as a1 b3 I cap dot k cap. So this is how we have multiplied this first term with all these three terms. We know similarly we need to multiply the second and third term with all these three terms. So overall we are going to get the 9 terms. By now we have got 3 terms. Let us write other terms quickly. Let's take this middle term a2j and multiply with this. So next we'll be getting as a2 b1 j cap dot I cap. then it will be multiplied with the next, so it will become a2 b2 j cap dot j cap. Then we can take this multiply with the last one, so it will become a2 b3 j cap dot k cap. This is how j cap will be multiplied with. 6 term we have got. Now 3 terms are left with this a3 k cap to be multiplied. So this will become a3 b1 k cap dot I cap. Then it will be a3 b2 k cap dot j cap. You can multiply with your own pace, and then finally is going to be a3 b3 k cap dot k cap. So whenever we have been given two vectors and we are supposed to multiply those two vectors in dot fashion, so we are going to put dot in between, we are going to expand, we are going to find out all the terms that are going to be there. We can multiply the scalars, put them together first, and then vectors has to be carry that dot sign. Now we have just talked about what the value of I dot I is. So I cap dot I cap is 1. So we are going to get this as a result, because we know this I cap dot I cap is unity, that's 1. So first term will be a1 b1 plus, can you think about what the second term is going to be? I cap dot j cap. I cap and j cap, they are perpendicular vectors, we are performing dot product, so this answer is 0. So you'll find this term will be cancelled out and it will be 0. What about this third term? Again two perpendicular vectors dot product, so this will become 0. What about this next term? This is again two perpendicular vectors, so their dot product will be 0. Next survival will be this a2 b2, because j dot j is a unity. So next term we are going to get as a a2 into b2, and j dot j will become 0. So there will be no cap coming in the answer, because we know this is a scalar product, so there will be no cap or vector on the right hand side. When we proceed further, we will find this term will become 0, because again product of dot product of two perpendicular vector. Similarly this will become 0 because it's a dot product of two perpendicular vectors. This is also 0 because dot product of two perpendicular vectors, and this won't be 0 because this is k cap dot k cap, and as per our calculation or understanding, that's the unity, so it's going to be a3 b3. So you can treat this as a formula. Whenever we are multiplying this a vector with dot fashion with this b vector, then our answer is going to be this. So people remember this as a result for this scalar product or dot product. So if a vector is given like this, b vector is given like this, then answer of a dot b is very simple. It's a1 b1 plus a2 b2 plus a3 b3. What does that mean? It simply means coefficient of I, that is a1, then coefficient of I in this expression, which is b1, they gets multiplied. That means when the two vectors are given to us, we will simply look at the coefficient of I and I, they will be getting multiplied together. Then we will go ahead and talk about coefficients of j cap and multiply these two coefficients together, so a2 b2. Then we will look at the coefficient of k cap, we will multiply them together, then will become a3 b3. Then we will sum all these products to get our answer back, right? So dot product will become very easy if we remember this relation. Or what we can do, we can expand it, we can find it out. There is going to be 9 terms. Out of this 9 terms, 6 terms are 0, only 3 terms are going to survive, because dot product of same vectors, unit vectors, is 1, whereas the dot product of different perpendicular vectors, unit vectors, they are 0, right? So that's an important relation we should remember. Let's consider an example based on this learning of dot product of two vectors. So this example says let vector A is I cap plus 2j cap minus 2k cap. B vector is given as a 2i cap minus 2j cap plus k cap. We need to find two subparts. One part is A dot B. We need to find the value of A dot B, and the second part is angle between vector A and vector B. So you can pause and solve by your own, otherwise you can watch over here. So first part we will start with, we are interested in finding A dot B. So how to get this A dot B? So we have understood A dot B, there's a formula, we can remember that formula, or we can put them in this way: A I cap plus 2j cap minus 2k cap, and then there is going to be dot in between, 2i cap minus 2j cap plus k cap. So whatever A and B are given to us, we can place over here. Then we can expand. We know there's going to be 9 terms coming in, but we have understood that 6 terms of them going to be 0. So what's going to be surviving? I coefficient with I coefficient. So this is 1. So 1 into 2, that's going to be 2. I'm writing directly. So it's a A1 B1, which is 2. 1 into 2 is 2, plus A2, which is 2, into B2. B2 is minus 2. So 2 minus 2, which will be minus 4. And plus A3, which is minus 2, B3, which is 1. So here was also 1. So this is going to be A1 B1 plus A2 B2 plus A3 B3. So if you remember that, so it's going to be simplified and we can get our answer. So it's going to be 2 minus 4 minus 2. So this will ultimately leads to one answer. That means A dot B is going to be equal to minus 4, right? So that will become our answer. So there will be an option like minus 4. You need to mark that option. And we are as expected that A dot B is going to be scalar number. So ultimately we will get as a number, and this is coming as a negative number. We know this A dot B can be positive, negative, or 0. So that's our first part. Making sense? So what we have used is formula A1 B1 plus A2 B2 plus A3 B3 in order to get A dot B. Or you can expand and use I cap dot I cap is 1, J cap dot J cap is 1, K cap dot K cap is 1, and I dot J is 0, J dot I is 0, and similarly any two perpendicular vectors dot is 0. Next part is to find the cos theta. That means angle theta between A and B. We know this cos theta formula. Cos theta, that is angle between two vectors, can be written by this formula, in which we require A dot B. That means dot product of two vectors, and we divide them with magnitude of A and magnitude of B. So we can find these magnitudes A and magnitude B. Now we know the magnitude of A will be written by square root of, we have already talked about how to get the magnitude of a vector. So it's going to be 1 square, first coefficient, plus 2 square, plus minus 2 square, or this minus 2 whole square rather. If you place them, simplify them, then you are going to get is a 1 plus 4 plus 4. That's going to be basically 8 plus 1, that's 9. So this will simplify to 3. That means magnitude of A is 3. Can we find similarly the magnitude of B? Magnitude of B is going to be calculated by its coefficients or components. So it's going to be 2 square plus of minus 2 square plus of 1 square. So it's going to be 4 plus 1, that's 9. Again it's going to convert into 3. So A is a 3, B is a 3. Now we can use this formula. A dot B we have calculated how much? That's the 4 with a minus sign, minus 4. A value is 3, B value is 3. So 3 into 3, that will become 9. So our answer will become minus 4 by 9. So if we are interested in finding theta, so we can say the value of theta for this particular case is going to be cos inverse minus 4 by 9. So you'll get this kind of an option out of 4 options. You need to mark that. So here we are able to find the dot product of two given vectors, and we also are able to find the angle between these two given vectors. So this is an illustrative example that talks about, you will get this kind of problems and what we need to do. So whenever asked about dot product, go use the formula A1 B1 plus A2 B2 plus A3 B3 that we have just understood and derived. And angle between two vectors, that's very important. So you will be given two vectors and you will be asked find the angle between these two vectors. So what we are going to do, use this cos theta is equal to A dot B divided by A magnitude B magnitude. How to get the magnitudes we know. How to get this A dot B we have just talked about. Hence we can get the value of theta angle between these two vectors. I hope it's making sense. If it is, we are on the right track. Now let me give you a homework problem based on the understanding of this particular video lecture. So there is a homework based on this dot product. So it says if a vector is 2i cap minus 3j cap plus zk cap, so this z is unknown, and this b vector is given over here, they are perpendicular to each other, then we need to find the value of z. So we are looking for the value of z. For what value of z? These two vectors are going to be perpendicular to each other. So you can solve this, and after solving, give the answer on the comment section. You can give that answer. So just a hint I can provide you. These two vectors are perpendicular. So we know whenever the two vectors are perpendicular, their dot product is 0. Okay, and if you catch this, it's done. So what do you need to do? You need to go for the dot product, put it 0, you will get your answer. So this is the question that you can use, and similar type of question has come in the examination as well. So that's important for us. So in this video, the important aspect that we have talked about is dot product between two vectors, and we also talked about multiplication of a vector by scalar as well as subtraction of two vectors. So this is an important video lecture, and you make your notes and write down everything. If you have question, you can ask. That's all. Thank you for watching. Have a great time.